Alright. Today we are working on inverse functions. So far you've done your functions. So now we're going to take it and invert it and come up with our inverse functions. So an inverse function is formed by switching the x and the y values. And our notation for it is f to the negative 1 of x. That's our notation we use when we talk about the inverse. So this is saying that this is the inverse of the f function. If I wanted the inverse of the h function, then I would write h to the negative 1 of x. It's whichever function you're dealing with, you just take it and put it to the negative 1 power, and that's your notation for your inverse. So what ends up happening is your domain of your original function becomes the range of your inverse. And then it flip-flops. The range of your original becomes the domain of your inverse. And then it's very important for us to note here that a function must be one-to-one in order for the inverse to be a function. If the original function is not a one-to-one function, then your inverse is not even going to be a function. So the original has to be a one-to-one. So let's take a look down here. So to find the inverse of a function, I'm going to show you the three different ways. If you've got your points, if you got a graph, and if you got an equation, there's three different ways to find it. So if you have your ordered pairs, all you're going to do is switch your x and y values. So here I have the function 163720. So the inverse of that function, so my f to the negative 1 of x, would be the points 6,1. I've just flipped the first one. And then the 0.73. Again, I just flipped it. And then the 0.02. So if you have your points either in a table or in a set of points like this was written, you just flip your x and your y values. So if you have a graph of it, to find the inverse on the graph, you have to reflect it in the line y equals x. The line y equals x is our inverse line. So that is a line that goes right through the origin, and it has a slope of 1, so it goes up 1 over 1, up 1 over 1. Generally, it gets drawn as a dotted line on your graph. So then what you would do is you would take whatever graph you're given. In this case, we're given that graph up there, the f of x, and you would reflect it over that line. I generally find sometimes it's a little difficult to actually reflect it over the line and be 100% accurate. So what I do is I find the points on my graph, and I do like what I did above, and I switch my x and my y's. So this is the 0.01, so my inverse is going to have the 0.10. My next point on my graph is the 0.12, so my inverse is going to have the 0.21. And then I have this point up here, which is the 0.24, so my inverse is going to have the 0.42. And then I don't have any other points that line up nicely on my original graph, so I'm just going to kind of sketch the rest of it, and it should look like that. So then if I were to take my piece of paper and fold it along that line y equals x, my graph and its inverse would line up with each other. Alright, so looking at the last part, if you are trying to find your inverse from an equation, that is a little bit more difficult. You got a couple extra steps there. So first thing you want to do is substitute y in for f of x. So if your equation does not already have a y in it, you want to put a y in there. So like looking over on the side, we have the function f of x equals 2x plus 5. So I'm going to make this y equals 2x plus 5. So that's our first step. Replace your function notation with a y. Second step, switch your x and your y. So instead of y equals, it's going to become x equals 2y plus 5. So then your third step, you're going to solve for y. So over in our example there, first thing I would do is subtract my 5. So I get x minus 5 equals 2y. And then what's my last step to get the y on its own? Divide by 2. So x minus 5 over 2 equals y. So then our last step, step 4, you're going to replace your y with f to the negative 1 of x. So you're just replacing it back with your function notation. So that's our inverse. F to the negative 1 of x equals x minus 5 all over 2. Alright, find the inverse of g of x equals x over 4 minus 7. So again, just like I have written, my first step is to replace my function notation with a y. So I'm going to have a y equals x over 4 minus 7. So then our second step was to flip or switch your x and your y. So now this is x equals y over 4 minus 7. So then again, our third step, we're going to solve for y now. So I'm going to add my 7. So I get x plus 7 equals y over 4. How'd you get that? Yes, multiply both sides times 4. So we get 4x plus 28 equals y. So then I'm just going to go back into my function notation. So g to the negative 1 of x equals 4x plus 28. That's our answer. There's nothing to solve. They just said find the inverse, so we found the inverse. Alright, let's take a look at the next one. That's telling us to find h of negative 1 of 2 if h of x equals x squared minus 2. So what we have to find first is we have to find our inverse to get that h to the negative 1, and then you're going to plug a 2 in for your x. So let's find our inverse first. So y equals x squared minus 2, plugging in my y for my h of x. Switching my x and my y. So now we're going to solve for y. So we'll add our 2 over. How do I get rid of that squared on my y? And then what goes out in front of the square root? What am I always writing? Plus or minus. Always writing plus or minus on your papers. No, it's just y squared. And then I took the square root. So again, I bring in my notation again. So plus or minus the square root of x plus 2 equals negative 1, or h to the negative 1 of x. So now that we have the inverse, we can go ahead and plug our 2 in for our x. So h to the negative 1 of 2 goes plus or minus 2 plus 2. Which, what is 2 plus 2? 4. And then the square root of 4? 2, so we get plus or minus 2. Alright, so again, we're finding g to the negative 1 of a minus 3. So we got to first find g to the negative 1 of x. We got to find our inverse. So y equals 1/2 x plus 4. First step is always make sure we have a y there. So now we flip our x and our y. So I get x equals 1/2 y plus 4. And now we solve for our y. Very good, minus our 4 first. And then what do? Casey, what do? Very good, Casey. So now what are we plugging in for our x? A minus 3. So that becomes 2 times a minus 3 minus 8, just like we were doing before, plugging that a minus 3 in for our x. So distributing our 2. And then what's our final answer? G to the negative 1 of a minus 3 equals what? 2a minus 14. There we go. Okay, number 4 says h of x equals x squared plus 4. They want us to find h to the negative 1 of x. And then they got a couple of questions about it. So let's first find our inverse like they told us to do. They told us to find h to the negative 1 of x. So that means find our inverse. So I plug my y in there. What's my next step? Switch them. So we get x equals y squared plus 4. Now we're going to solve for y. And then what do we do now? Square root it. Good. So we get plus or minus the square root of x minus 4 equals y. So then I'm going to put it back into my function notation. So h to the negative 1 of x equals plus or minus the square root of x minus 4. So that was our first part. They wanted to know what the inverse was. There's our inverse. We found it. So they want to know, is h to the negative 1 of x a function? So this goes back to that little note we had back on the first page. Your inverse is a function if the original is a 1-to-1 function. So is that original one a 1-to-1 function? No, what shape is that graph? That's a parabola. So that would be up here like this. It is a function, but it fails your horizontal line test. So that means it's not a function. So therefore, the inverse is not even a function at all, because the original one is not 1-to-1. So what they want us to do is they want us to restrict the domain of the original so that the inverse does become a function. So what we want to do is we basically just want to get rid of one of these sides here. So now this would be a 1-to-1 function because it would pass your horizontal line test. So which values of x would I be using here? Positive ones. So your h of x, your original function, where the domain is greater than or equal to 0. If you have just the numbers that are greater than or equal to 0, your inverse would then be a function. Pretty much that's the way it's always going to work out. If you got to change it to be 1-to-1 in the original, you just want to make it the positive values. Alright, 2 more questions. 5, verify that f of x equals 3x plus 5 is the inverse of g of x equals x minus 5 over 3. So to prove that this is the inverse of this one, I'm actually going to take this one and go through the steps to find its inverse. You could. Yeah. Okay. So first I put my y in there, and then I switch my x and my y, so it's now x equals. What do I multiply both sides times to get rid of the 3? Times 3. So I get 3x equals my y minus 5. And then what do we do with our 5? Add it. Does it match? It sure does. So those are inverses. And then our last question there, it says, if the point negative 3, 5 is on the graph of y equals f of x, then name a point on the graph of its inverse, f to the negative 1 of x. Since it's just the inverse, all you got to do is take this point and flip it. So a point on the inverse would be 5, negative 3.